So there's orders of lipoprotein metabolism. We have primary hyperlipidemia and secondary hyperlipidemia. So for the primary hyperlipidemia, that is when the problem is due to inherited disorder of lipoprotein metabolism, okay, for which specific gene defect have been identified. Example, familial hyperlipidemia. So this one, there is inherited disorder of lipoprotein metabolism. So it could be that there are some defects in some genes. There are some problem here. It's genetic, inherited disorder. Okay, so always remember that. And of course, the first one we talk about is familial hypercholesterolemia. Okay, familial hypercholesterolemia. This one is autosomal dominant inherited defect of LDL receptor. Now LDL receptor is basically needed for the transportation of LDL from circulation. Okay, so in this case, when there is autosomal dominant inherited defect of this LDL receptor, it could be that it will still be in circulation. You understand that? Because since there is defect in the inheritance of this receptor, HDL will be in circulation and you get high amount of cholesterol. So homozygotes have very high cholesterol levels and usually die of CAD before 20 years. Homozygotes, very high cholesterol level, okay, greater than 15 millimolar. They usually die of CAD before 20 years. There's high levels of cholesterol and LDL. Yeah, you also if you look at the endogenous pathway, okay, after VLDL, the last protein, the ApoC, will be transported to HDL. Okay, VLDL is converted to LDL. Okay, so LDL is finally converted to HDL, but the LDL is picked from circulation through this receptor on the liver. So if there is defects in its inheritance, this LDL will still be in circulation, and then cholesterol will also be there. Okay, triglyceride and VLDL may increase in 30% cases. So meaning that triglyceride and VLDL are not common. Okay, but in 10% cases their levels too can increase. Okay, so another one is familial binding defective ApoB100. Familial binding defective ApoB100. In this case, it's a single base change in the cDNA for ApoB100, which decreases binding to the LDL receptor. The ApoB is found on the LDL, right? So the LDL receptor recognizes ApoB, so that you understand that. So if there is a single base change in this DNA that synthesizes this receptor, it means that the receptor may not be, able to bind this ApoB, and so you see that it decreases the rate of clearance of LDL from plasma. That causes hypercholesterolemia. So cholesterol will be in the blood because of the defective function.